Coastal regions provide value, aesthetic and a range of diverse ecosystems. As a result, this constitutes in one of the most heavily populated and developed land zones in the world. Cliff recession occurs because of the balance between the durability of the cliff geology and the coastal forces imposed, such as spatial erosion, slumping, landslides and rockfalls through gravity and kinetic energy from the wave. This can be portrayed in the reduction of elevation and sediment volume on the beach/cliff and quantified using different rates of change through different temporal and spatial scales. These rates of change tend to be episodic, with intermediate large changes occurring in a short space of time, followed by little to no change in a short space of time. The weakly cemented Mesozoic rocks and sediments that form the coastline stretching between Charmouth and Golden Cap are sensitive to morphodynamic fluctuations. Forcing conditions such as wind, waves, tides and currents vary as a function within this coastal system and having the potential to affect beach width and cliff retreat. Highlighting potential correlations between coastal processes in relation to cliff retreat and beach width through time is crucial in understanding how a coast may function in the future. By conducting this project, data collected from Google Earth Engine would broaden our knowledge and understanding of the relationship between cliff retreat and beach width at a time where there is an increased concern regarding coastlines in response to climate change. This project aims to assess the relationship between cliff retreat and beach width along the coastline between Charmouth and Golden Cap. To achieve this aim, the project will address the following objectives. To calculate the rate of cliff retreat and how it varies through time between 2001 and 2020 along this 3.5 kilometre section of the Dorset coast, to measure the beach width and how it varies through time along the same coastline, and to identify whether the cliff retreat contributes to increasing the beach width at this section of the Dorset coast. Beach width and cliff retreat measurements were obtained through Google Earth Engine between 2001 and 2020 along the Charmouth and Golden Cap coastline. A 3.5 kilometre baseline was made using the path feature being split into 10 350 metre sections spreading 250 metres perpendicular to the coast. Beach width calculations were made by identifying the back barrier of the beach and the water's edge, then measuring the width at the start, middle and end of the transect to get an average for 2020, 2006 and 2001. The same process of measuring at 3 different intervals was applied for the cliff retreat, but repurposed to identify average rate of change between 2020 and 2006, 2006 and 2001, and 2001 between 2020. As shown in Figure 1, the average rate of cliff retreat between 2020 and 2006 was 6.59 metres, with an average beach width of 15.86 metres, whilst the average rate of cliff retreat between 2006 and 2001 was 3.22 metres, with an average beach width of 10.64 metres. Finally, between 2001 and 2020, the average rate of cliff retreat was 8.64 metres, with an average beach width of 16.26 metres. As presented in Figure 3, the average rate of beach width for 2001 was 10.78 metres, for 2006 11.56 metres, and for 2020 21.74 metres. Findings from the results suggest that there is a relationship between the rate of cliff retreat and beach width along the coastline from Charmouth to Golden Cap. Between 2020 to 2006 and 2006 to 2001, there has been a 104.7% increase in cliff retreat and 45.02% increase in beach width, implying that there is a strong relationship between these two variables. The more cliff retreat occurring, the wider the beach was along this stretch of coastline. However, due to long gaps in data between 2020 and 2006 having a 14-year difference compared to the 2006 and 2001 only having 5-year difference, the values become slightly invalid. The area between Charmouth and Golden Cap are particularly prone to these variations as shown from these maps, resulted in the beach width over time increasing in conjunction with cliff retreat. As shown from this section, between 2006 and 2020, the beach width has increased by 58%, a major landslip increasing the volume of the sediment supply along the coast. However, from 2001 to 2006, the beach width has only increased by 7.3%, potentially highlighting that the landslip has had a significant impact on the beach width. From this project, it should be taken away that identifying and understanding the relationship between beach width and cliff retreat is crucial in going forward and possibly mitigating around how to deal with these changes.